Hello, welcome back to the channel, and in this tutorial I'm going to show you how to set up and program an ultrasonic sensor to calculate distances on your Arduino project. Today we're going to take a look at the most popular ultrasonic sensor, the 8C-SR04. At a first glance, you would notice that there are four pins located at the bottom of the sensor: VCC, GND, trig, and echo. VCC powers the sensor, and GND is the ground, but the two most important pins are the trigger pin and the echo pin. But how do we use the ultrasonic sensor to actually measure sound? For that, we need to set the trigger pin to high for 10 microseconds. This activates the transmitter, which sends out an ultrasonic sound wave for that duration. These sound waves travel through the air, and when they hit an object, they bounce back toward the receiver. The receiver picks up the echo, causing the echo pin to go to high. We then measure how long the echo pin stays high using the pulse in function. The time the echo pin stays high represents the round trip it took for the sound wave to travel to the object and back. To find the distance, we use this formula. We take the time the echo pin was high and then multiply that by the speed of sound in air, which is roughly about 0.0343 centimeters per microsecond, and divide that by 2. We divide by 2 because we want to know the one-way distance, not the full round trip. For this project, you only need two main components: the Arduino Uno R3 and the 8C-SR04 ultrasonic sensor, and four more other wires. Our first connection would be the 5 volts of the Arduino Uno to the VCC of the ultrasonic sensor. Then we would want to connect the ground of our Arduino to the ground of the ultrasonic sensor. Then we would want to connect the trig of our ultrasonic sensor to digital pin 7 of our Arduino, and digital pin 8 of the Arduino to the echo pin of our ultrasonic sensor. But if you want a more cleaner version of this, you could use a breadboard. Now let's code this circuit. Thing you have to do is you have to create these four variables. We'll call the first one echo and give it the value of 8 because that is the digital pin we plugged our echo pin into. We'll also do the same for our trig pin. Next, we'll declare a variable called duration, but we're going to make this a long type because this variable will store the time it takes for the sound to travel to the object and back toward the sensor. If we were using an int, the variable would be overwhelmed, but a long type could store far more values. Let's define another variable called distance, which is going to be responsible for storing the calculated distance between the sensor and the detected object. Now in the setup function, we'll use the pin mode function to set the echo pin as an input. This tells the Arduino that this is going to receive data from the sensor. For the trig pin, we will set that as an output, so the Arduino knows that this pin will be used to send data to the sensor, especially to trigger the transmitter to send an ultrasonic sound wave. Our last step would be to initialize the serial monitor. In the void loop function, we will use the digital write function to set the trig pin to low. We're doing this so that we could avoid we could avoid the transmitter activating before we wanted to. And then let's add a small delay so that we don't get false readings. After that, we'll use our digital write function again to set the trig as a high. This is going to activate the transmitter to emit the ultrasonic sound waves. Then we'll use another delay of 10 microseconds to give the sensor enough time to emit the ultrasonic sound waves. Then we'll set the trig back to low so the transmitter stops emitting the ultrasonic sound waves. After that, we need to measure the duration of the high signal coming from the echo pin. We'll store this value in our duration variable, and we're going to calculate how long the echo pin stayed high using the pulse in function. Now, Let's write an if statement. We're going to write this if statement to check if the duration is greater than 0. We are doing this because if the duration is greater than 0, that means we have a valid echo. In it, we're going to calculate the distance. So this is the formula we talked about. The speed of sound in centimeters per a microsecond times the duration divided by 2, which is our final distance. This is going to the final distance is going to be in centimeters. Now we would want to print all this onto the serial monitor. So let's use the serial print function to uh, print the text distance so we know what we're displaying. Next, let's print the actual distance using the distance variable. And remember, we're using a serial print here too, and not a print ln. Next, let's add a centimeter text to indicate that the measurement is in centimeters. But if the ultrasonic sensor can't detect an object that's too far away, let's display the message out of range. And outside the if statement, we are going to add a delay of 500 so that the serial monitor doesn't get overwhelmed with too much data. And that's it. We've built a simple Arduino sketch to measure distance using an ultrasonic sensor. Now let's actually test this to see if it actually works. So here is our circuit and here is our code. And let's start the simulation to see if it actually works. And ooh, it actually works. Let's move the object around and we will also always get the perfect uh, distance. Now go out and create your own ultrasonic sensor project. See you in the next one.